Hello everyone! Today's topic is inquiry-based learning, and I'm going to be interviewing Gabor Orosz, a researcher from Hungary.
It's my pleasure.
And I'm really happy to be interviewing him today because his research group was actually one of the winners of START-E 2017, and they were also one of the nominees in 2018.
Yeah, that's true.
Congratulations for that.
Thank you.
And the research group has a special focus on inquiry-based learning, and Gabor is also doing his PhD on inquiry-based learning. But before we go into that, I would like to ask you about your experiences with START-E. The research group decided to participate in START-E.
The aims of START-E, like active learning, learning from each other, sharing knowledge, are something we have always sympathized with. In the MTA-STE Science Education Research Group, where I work, we examine the development of scientific reasoning and inquiry skills, and we make new teaching materials to foster these skills. So carrying out the interdisciplinary projects of START-E contains many opportunities to do that in practice.
I see. And then I'm also interested that, based on your research group's experiences, why would you recommend START-E for other people?
Firstly, project-based learning is fun. You can see in the videos that students really enjoy.
That's true.
Secondly, this type of learning is challenging, so they need to do their best to carry out the investigations and design the artifacts. They need to think critically, solve problems, use their creativity, communicate with each other, and so on. So they could learn many things during this. Thirdly, with sharing their experience, participants could influence how local people think about science and education and show good examples of meaningful learning.
Yeah. Thank you for your comments. Let's now talk a little bit about inquiry-based learning then. So, project-based learning can actually be considered as a variety of inquiry-based learning. And my first question to you would be, if you had to summarize inquiry-based learning with a few sentences, what would you say?
It is an active learning method where students follow the steps that scientists take during the process of knowledge building. It starts with an observation, a problem or a question, and children will carry on gathering information and data to answer the question or solve the problem.
So it seems to me that it's very similar to project-based learning. What would you say is the difference between them?
I would say the emphasis is placed on different aspects.
Yeah.
So during IBL, we focus more on data collection and analysis. So basically we emphasize the scientific practice more.
Yeah, I see. But actually the use of scientific practices should be included in project-based learning too, especially if you're making a science project.
Exactly. Another difference is during PBL, we always share what we have learned with a broader audience by showing them our artifacts, for example. So communication is more in the center of attention.
Yeah.
However, in IBL, it is not necessary every time. So we can still write reports or make presentations, but the classroom discussion is sufficient enough as well.
You're right. And actually one of the reasons that we create the artifact in project-based learning is to make students' learning visible for themselves and also others. And the core idea behind everything in project-based learning is to consider students' thought processes and the development of their thinking skills, like how their understanding develops once they create the artifact during the project.
Yes, absolutely. The foundations for IBL and PBL are indeed similar.
They are. And now I think we should go through the phases of inquiry-based learning to get a better idea on how to add some inquiry to your project.
Yeah, let's do that. So, generally in the literature, the phases are the same, but their name could be different. Now we will use the framework of Pedasty et al. So let's go through the steps. As you can see here, the first is orientation, then comes conceptualization, investigation, conclusion and discussion.
And I'm noticing that some arrows are pointing backwards, so that probably emphasizes that carrying out inquiry is not a linear process?
Yes, you are right. It definitely isn't. For example, discussion happens throughout the whole process. Moreover, most of the steps could be repeated if needed. So, for example, let's say we found that something is wrong with the planned experiment. We could modify the design and conduct it again.
Yeah, I see. And that is the case with PBL too. So, Could you explain a bit more what happens in practice during all the phases?
Yeah, the first phase is orientation.
Mm-hmm.
So here we decide the topic of inquiry. We could state the theme or ask students to bring their questions of interest. To tell the truth, I prefer merging the two together.
Yeah, I see.
So I usually introduce them to the topic in general, but let them to do research on what they are interested in. Yeah, in summary, it is all about defining the problem and motivating students.
I see. And I think that sounds really good because at the end of the day, it is the teacher who sets the learning goals, so the students learn relevant topics through this method.
Yes, actually. There are 3 different kinds of inquiry based upon the amount of instructions and freedom of students. So structured inquiry contains the most instructions and provides the least freedom to students, while open inquiry is like the opposite. Somewhere between the two, there is guided inquiry in which teachers introduce the topic, but the rest of the process is up to the students.
That is an important thing to consider, how much freedom that students have to make decisions. So, how would you describe the role of the teacher in inquiry-based learning?
As in other active learning methods, teachers have the role of a facilitator in IBL too. So instead of giving long lectures, they prepare the learning environment, coordinate the work, provide students with tools they need to carry out the investigations, and guide them. So, although it's really important, they should avoid spoiling the answers.
Yeah, that is exactly the same in project-based learning. So, how about the next phase of inquiry-based learning, conceptualization?
In this phase, we specify the topic further. So children start asking questions or formulating hypotheses. However, the latter is not always necessary. So we could have a perfect inquiry without hypotheses. During this phase, everything is about sharing ideas, therefore group work is especially effective. At the end of the phase, students have a research question and a hypothesis that will lead the further investigation.
And it is probably important that the teacher checks what the students have done so far at this stage to make sure that it's feasible.
Yes, you are right. That is crucial here, because asking good questions is not easy.
Yeah, no, definitely it isn't. Would you tell us about the next stage then, which is investigation?
This phase is the landmark of IBL.
Yes.
So students should plan how they investigate a research question or hypothesis scientifically. Experimentation is when they collect data by doing an experiment. However, if they make observations, use surveys or any other methods, then it is called exploration in the model.
And that is something that is definitely a part of project-based learning too.
Yes, and sometimes the problem in question is too complex. You need to do both, so they don't cancel out each other.
Yeah, absolutely.
And when they have the data, they will start analyzing and interpreting that.
So how can teachers support this?
Here the amount of supporting and scaffolding depend on students' age, previous experience and knowledge. If they haven't done anything like this before, it goes without saying we should teach them first. So we can introduce them the control variable strategy, for example, the different ways of data collection, analysis, and shape their views of nature of science as well. So you can see how many options we have here. It's truly rewarding.
Yeah, exactly.
Yeah.
How about the conclusion phase then? Would you tell us about that?
Yeah, here students consider the original question or hypothesis and examine whether these are answered, supported or not by the evidences. So they can learn new concepts, find out relations between variables, discover patterns and tendencies.
And that same thing happens again in project-based learning.
Yeah, another thing to remember here is that drawing appropriate conclusion could be challenging for students. So try to give them some more support for that.
Yeah, that is important to remember. Now, should we go through the discussion phase then?
This is the phase where students communicate their findings with others, give and receive feedbacks. Teachers should highlight the main steps and key concepts and clarify every misconceptions occurred, which is really, really important.
Yeah.
And this usually happens when the whole class is present.
Yeah, and this is quite similar then to project-based learning again, because like we said earlier, presenting and sharing the artifact that displays the developments of students' thinking is very important.
Yeah.
But how about reflection? Could you tell us more about that in inquiry-based learning?
Yeah. It is an inner conversation happening throughout the whole IBL in students' heads. It is like a self-evaluation. So they ask questions like, what did I do? How did I do? How could I improve it? And so on.
And yeah, that is definitely something that should happen all the time during project-based learning too. And it is one of the reasons why we create the artifacts and why making learning diaries is a great idea.
Yes, indeed. It really seems like these two approaches don't differ that much at all.
Yeah, no, I agree. And I think that they could support each other quite well.
Yes, absolutely. So it's worth considering the theory of inquiry-based learning and the steps when creating your projects.
Yeah, that would be really helpful when you're creating or thinking how to include scientific practices into your project, that you look a little bit about the steps of inquiry-based learning. Thank you so much, Gabab. I am really happy to have had you here.
Thank you, Anetta.